Hey everybody, welcome. Want to give everyone a chance to go and do a little bit of drawing today and also do a little bit of exploring and understanding in terms of how the atom is arranged and what we can learn from the arrangement of these particles. So I'm going to ask that you find yourself a piece of paper. Could be white lined or it could be a blank piece of paper, but find yourself a piece of paper and either a pen or pencil, and definitely at least let's go with a couple of highlighters. Let's go with about 5 highlighters. Okay. All right. So 5 different colored highlighters or crayons or colored pencils, something like that. So here's what we're going to start off with. I'm going to ask everyone to go ahead and start off by drawing this picture of an atom in the center of your screen. And of course, if you need a title, this is the atomic structure of helium. Excuse me. So the atomic structure of helium, at which point we're going to have you go ahead and draw this atom. We're going to focus on the atom for now, and then we'll go and worry about the information that we'd find on a periodic table shortly thereafter. So start off with a nice little circle right here. And on that circle, could you go ahead and draw these 2 negatively charged particles, one here and one on the other side? And we'll talk a little bit about the various types of atomic models, as this is a good one to use when learning about atoms, but may not necessarily be the most accurate in terms of how they exist in our universe. But for now, for today, I would greatly appreciate it if you were to go ahead and draw in these electrons on this outer energy level, this outer energy orbit. And then after you've gone and drawn your electrons, make sure you label them electrons, particles with a negative charge. And over here in the center of our atom, we're going to refer to this area as our nucleus. And we're going to draw 2 different particles. Please note the number. There's 2 positives. They're referred to as protons, and they are particles with a positive charge. And then we have 2 neutrons. Notice there is nothing in the neutrons, okay? And they are particles with a what we call no charge or a neutral charge. So go ahead and take this moment to go ahead and label neutrons, protons, electrons, and the energy level on the exterior portion of the atom. Go ahead and pause this video so you can go ahead and draw this atom. All right, I'm going to assume you're done pausing. And now we're going to go and expand our paper here with a little bit more information. We're going to go and add a little bit more. In fact, I'm going to ask that you just go ahead and, now that you've drawn your atom, if you would go ahead and draw in this information. So there's a box right here, this rectangular box, very similar to what you'd see in a periodic table of elements. But I'd like you to go ahead and draw in this box. And please note the location and the arrangement of things. There's a little bit of a format here that I'd like us to try and pay honor to. So He goes in the center of the box. That happens to be the chemical symbol for helium. We have a 2 in the upper right-hand corner, which happens to be referred to as the atomic number. We have the name helium, the chemical name right below. And we have this 4.003, which is our mass number or our atomic mass. Now, some of you are probably going to ask, how come some of them have rounded numbers and sometimes some of them have these longer decimal specific numbers? I would tell you that does have to do with the fact that the mass of these particles is not equal. Neutrons and protons are pretty close in mass. Electrons are a far cry from the mass of a proton or a neutron, something on the order of 1/1843rd of the mass of a proton neutron. I will confirm that in class today, but it is a very, very small, paltry, which is why it's not really always counted. But to be fair, and then when you get to neutrons and protons, they are not also equal. They're close to 1 atomic unit, but not exactly. So anyways, go ahead and take a moment to copy this down if you'd be so kind. Go ahead, pause the video, and copy down the box in the upper corner. All right, I'm going to assume you're done with the copying. And now we need to add just a little bit more to our paper. Could you please add, at the bottom of your paper, could you please add this information? We have atomic number, we have proton number, we have electron number, and we've got this little bracket here to remind us that these are all the same. All these numbers will always be the same regarding the atoms on the periodic table of elements. So please note, if you know the atomic number, by default, you also know the proton number and the electron number. And this kind of works out because, to be fair, a proton, which has a positive charge, and an electron, which has a negative charge, this is kind of one of those rules in the universe. Everything just really likes to be in equilibrium and balanced. And so if I had, I don't know, 2 positive protons and I wanted to balance my atom, I would need to have 2 negative electrons to balance the said atom. And so atomic number, proton number, and electron number will all be the same. So we should be copying this onto our paper, into our notes. And lastly, over here on the right-hand side, we've got a small little mathematical equation. It says mass number minus the atomic number equals the neutron number. Again, that's the mass number minus the atomic number equals the neutron number. Now, if you were to do a little bit of flipping around math, you know that we can take a subtraction and turn it into an addition. And so if I add my atomic number and my neutron number, so that's my neutron number plus my atomic number. But remember, the atomic number is the same as the proton number and the electron number. So if I add my neutron number plus my proton number, I get the atomic mass number, which, to be fair, is basically all the items here in the center of the nucleus. And so we can go and figure that out in a moment. So I'm going to zoom out here because I need you guys to do a little bit of highlighting here. So hopefully you guys have your highlighters handy. Excuse me. Go ahead and zoom out just one more click here. All right. Excuse me. Okay, so you've got your highlighters, and I'd like to go and address these numbers here. So you'll notice here at the bottom, we have a couple of almost acronyms jumping out at us. We have acronyms like APE for ape, and we have MAN, ape man, to kind of help us to remember these. And so I'm going to start identifying and putting some colors here. And so I do need my highlighter, and I'm going to go with, let's go with, I'll go with pink first. All right, and so we'll start off with the protons. So I'd like you to go ahead and color in your protons. And I'm going to color in this P over here too. Now that I've highlighted and colored in my protons, I'm also going to highlight over here the P over in the word proton. And I notice that's a little bit too thick, but I will definitely use that for the next one. All right, next up, I need to go and put in my other particles. And so I'm going to change my color up. I'm going to go to yellow here and click down. All right, now I'm going to tackle the neutrons in this case here. So I'm going to highlight the neutrons in the center here. And I'm also going to highlight the N in the word neutron. And I'm also going to highlight the N in the word neutron down here. All right, we're doing great. We're doing great. And please remember, at any point in time, if you need to pause the video to catch up, by all means, please do. Next up, we're going to shift gears to blue and make it even smaller. It's just me kind of figuring out. All right, so I need to go and color in these blue particles. These are called my electrons. And I'm going to highlight the E in the electron, and I need to highlight the E in this electron down here. All right, we're doing really good, folks. We do want to go and I need to shrink this up a little bit to add some more, but I think we're doing good here. All right, let's go and tackle some of these other parts of our periodic table, this box up here. So I need another color, and I'm going to go with, I guess this looks to be a bit of a green. Not green enough. Maybe we got a heavier green. There we go. All right, we got that green. So I'm going to tackle that with my atomic number. I'm going to put a green right here. All right, and I'm going to go and highlight the A in ape man, and I'm going to highlight the A over here in the man. And now, last but not least, I need to go and highlight one more number, one more item. Anyone know what it is? Great job. The atomic mass. Very good. Very good. So we need one more color here. How about maybe a purple? We'll go with a purple. All right. And that is over here. So I'm going to highlight the 4 and highlight the M right there. Now, don't also forget to highlight this M way over here. Now we can run through and we can see how this is arranged and how it is calculated. So I'm going to take a moment here to go and point this out. And I want to get nice, perfect. I'll go a little bit here. Okay. So let's talk helium. Let's go and discuss this helium and figure out why is it that we can go and calculate all of our numbers and we can see everything associated with helium. So we should probably go and identify helium does have an atomic number of 2. And we know that because it's the same number of protons and the same number of electrons. So if I was to go and fill in my paper with some information, I would go and write things like, I'd put a 2 right here, a 2 right here, and a 2 right here. Now I know that the atomic number, the proton number, and the electron number of helium are 2. Okay, and that's based upon my chart up above, this little here, plus just looking at things. I've got 2 protons. I got 2 electrons. Perfect. And now let's see if we can't work backwards to figure out our neutron number. Now, atomic mass, please note, that happens to be a 4. So if I put a 4 over here and I minus the atomic number, which we know again is 2, I subtract it, 4 minus 2 is indeed 2. And again, like I mentioned before, you can always take subtractions and reverse them. So if I was to try and figure out what is my atomic mass, I can go and say it's the atomic number, 2, plus the neutron number, 2. 2 plus 2 equals 4. Another little shortcut there. The atomic mass is always based upon the particles that have substantial mass, and that is your neutrons and protons. And so if you were to count up the particles in your nucleus, you would now find that that is the same as the atomic mass. And so through the combination of APE and man, we're able to go and identify all the connections and the connecting points between the atomic structure of helium. We're able to go and identify the parts of the periodic table here and see how that looks in the actual atom. And we can work with calculating and counting to figure out, remember, APE, APE, atomic number, proton number, and electron number, they're all the same. And the man, or mass number, minus the atomic number equals your neutron number. So, ladies and gentlemen, if you are done with this information, you're going to use this to go and fill in a chart that you're going to find a lot of missing spaces and gaps. So, thank you very much. Make sure that if you haven't gone and finished doing this, that you finish copying everything you see and highlighting as you can. All right? Thanks a lot, everybody.